Assalamualaikum warahmatullahi wabarakatuh, and good day. My name is Muhammad Shahrul Radzzi bin Amirudin. Number matric is CN200105. My supervisor for this project is Technologist Dr. Muhammad Hazri bin Muhammad Louis at Mota, and I am in semester 1, session 2022/2023, and I am in the Department of FTK. So right now I'm going to present about my project of PSM1, and my title for for my project is the development of train vibration monitoring system for future mitigation. Next, introduction. The transportation industry is significantly influenced by trains, which also offer a number of advantages. Train vibrations may annoy and agitate people who commute using trains. The system uses SW420 sensor to detect vibration in railway. For GPS module, which is GY-NEO6M version 2, is to record the location of the vibration. The data then collected and stored using MicroSD Card. This project mainly focusing on the hardware part. Next is Gantt chart. For the first week, we brief with our supervisor for PSM1, and second week preparing for the proposal of PSM1. For the third and fourth week, doing some research and literature review for the project, and the next fifth and sixth week, designing the 3D model and preparing all of the materials and components that needed to use for this project. And for the next 5 weeks, doing methodology and some correction of the report. And the week of 12th, report will be submitted in the SMAP platform. And lastly, for the 30th and 40th week is the final presentation of PSM1. Next, this is the flowchart of PSM1 progress. So firstly, start, then go to finding our supervisor, then discussing about the topic selection, and if the topic is not relevant, then the supervisor will change the title. So if yes, we go straight to doing our proposal. So if the proposal is not correct, then we will go back doing the proposal. So if yes, we go straight forward to the literature review, which we find our research in thesis, books, or internet. So then we go straight to methodology. Doing methodology, then the methodology consists of circuit design. So if the circuit design is wrong, we do it again. For my circuit design, it uses ESP32 SW420 and GPS module and MicroSD card, which we store the data. So this if the components is complete, then we go straight to simulation, and then it needs a little bit of improvement and recommendation. If not, then we go restart again and do the circuit design for the correction. So, and then go straight to discussion and conclusion. And then preparing for the FYP1 thesis. So if the thesis is not okay, we do some correction. And lastly, if the thesis is good and correct, we will present to the supervisor and then to the panel, and that's it. Next, problem statement. The vibration produced by a train can have physical effects on the train itself and its surroundings. The vibration may also affect the comfort of passengers on the train, and it may be a source of the noise. So the vibration produced by a train can have social effects on the communities it serves. Objectives. First, designing the circuit for train vibration monitoring system to implement towards the prototype. Second, develop a portable prototype that can be used to monitor the frequency of train vibration when it starts moving. And lastly, collect and analyze all the data, that the train vibration data, for future mitigation and improvement. So for the scopes, the system enables monitoring of the frequency coming from vibrations of the train by using the prototype. Next, the prototype capable of capturing any incoming vibrations of the frequency for 1 to 5 seconds to assign the frequency are accurate and precise. The system establishes functional connectivity through the hardware, allowing the microcontroller to communicate with other devices. The track that being tested from Gombak to Putra Heights. It will be approximately around 1 hour and 30 minutes journey from point A to point B. Next is expected results. So for the expected result of the vibration sensor system will depend on the requirement of the system, such as the primary function of the system will be to detect vibrations. Sensor will produce an output signal when a vibration is detected. GPS module will provide data on the location of the system. Data will be stored in MicroSD card for future study. Next is introduction of literature review. This study mainly to examine the different types of vibration sensors that are available, the microcontroller and other hardware components that are commonly used in this system, and the software algorithms and techniques that are used to process and analyze the sensor data. So for the first previous project that I found, the title, which is implementation of railway doors using vibration sensors and ultrasonic sensors based on Arduino Uno. The description of this project the implementation of railway doors using vibration sensors and ultrasonic sensors based on Arduino Uno is a proposed system that aims to improve the safety and efficiency of railway transportation. The system utilizes vibration sensors to detect the presence of trains approaching the station and ultrasonic sensors to measure the distance between the train and the platform. When a train is detected, the doors will automatically open to allow passengers to board and disembark safely. So for the next previous project is use of vibration sensor as detection of railway in mechanical signaling systems. The use of vibration sensors as detection of railway in mechanical signaling systems is a proposed solution that aims to improve the safety and reliability of railway transportation. The system uses vibration sensors placed along the railway tracks to detect the vibrations caused by approaching trains, then processed by a microcontroller which sends signal to mechanical relays to activate the appropriate signals. This can improve safety and reduce maintenance costs, while also improving the efficiency of railway operations. For the third previous project, which is vibration measurement and analysis using Arduino-based accelerometer. Vibration measurement and analysis using Arduino-based accelerometer is a proposed solution that aims to improve the understanding and control of vibrations in a variety of industrial and research applications. The system uses an accelerometer sensor to measure vibrations and Arduino microcontroller to collect and process data, which can be used to monitor machinery, analyze building vibration, and study the effect of earthquake. The system can also be configured to set alarm threshold and store data for later analysis. Next, analysis of the SW420 vibration sensor performance on vibration tools by using fuzzy logic method. The analysis of the SW420 vibration sensor performance on vibration tools using fuzzy logic method is a proposed study that aims to evaluate the accuracy and reliability of the SW420 vibration sensor in measuring vibrations in tools such as hammer drills and impact wrenches. The study will use a fuzzy logic method to analyze sensor data and determine the sensor's performance in different operation conditions. The result of this study can be used to improve the accuracy and reliability of vibration monitoring systems and guide the selection of sensors for similar applications. So for the last previous project that I found is train collision avoidance system using vibration sensor and ZigBee technology. The train collision avoidance system using vibration sensors and ZigBee technology is a proposed solution that aims to improve safety of railway transport. The system uses vibration sensor placed along the railway tracks to detect the vibration caused by approaching trains and ZigBee technology to wirelessly transmit this information to other trains in the vicinity. This allows for trains to take appropriate action to avoid collision, leading to improved safety and more efficient railway operations. Next is the table of comparison. This is the comparison based on the 5 previous project that I found. So for the first project, there are advantages, disadvantages, hardware use, software use, technology use. So we look at the advantages for the first project. The advantages are vibration sensors and ultrasonic sensors can accurately detect the presence of object or people in the doorway, helping to prevent accident. For the disadvantage of project 1, ultrasonic sensor may affect environmental factors such as temperature, humidity, and humidity, which could affect their accuracy and reliability. The hardware used for project 1 are Arduino Uno, ultrasonic sensor, LCD, buzzer, and servo motor. So for the software use, which is Arduino IDE, and the technology they use RFID technology. For the second project, the advantages is vibration sensor are generally reliable and can operate continuously without the need for maintenance. The disadvantage is any mechanical or electronic system has the potential to fail, and vibration sensors are no exception. The hardware they use Arduino Uno, SW420, relay, LCD, buzzer, and LED. And for the software, they only use Arduino IDE. For the third project, the advantage is they able to provide data with a minimum amount of error. Also, it is more efficient for safety purpose. The disadvantage is difficult to connect multiple interface device into a single pin SDA and SCL for Arduino Mega. The hardware part, they use Arduino Mega ADSL345 LCD display, Wi-Fi module, piezoelectric, ESP8266, and power supply. And for the software, they use ThinkSpeak, Blink, MATLAB, and Arduino IDE. For the technology, they only use the accelerometer system. For the fourth project, the advantage is results using fuzzy method are more accurate and little error to consider using vibration sensor when collecting data. The disadvantage which is the delay on the sensor results in data not being successfully received because the sensor detected while it is still in delay process. For the hardware part, they only use 2 components, which is Arduino Uno and SW420, and same goes to the software, they only use Arduino IDE. And the technology, they use the fuzzy interference system. Last but not least, the last previous project, the advantage is the project able to reduce train collision by implementing wireless technology and ZigBee communication, and it can save life of rail passengers and road users. The disadvantage false alarm could potentially lead to unnecessary delay or disruptions in train service. The hardware part, they use ARM7 LED, laser, piezoelectric, laser detector, piezoelectric, and buzzer. And the software, they use Kill UVision for IDE. For the technology part, they use alarm system, PLC system, and ZigBee. Next, we go to the discussion based on comparison. So, this in project 1, this system uses vibration sensor to detect the presence of a passing train and ultrasonic sensor to measure the distance between the door and any objects that may be in their path. In project 2, this system uses vibration sensor to detect the vibration caused by a passing train and then sends a signal to the signal system to indicate that a train is present. In project 3, this system accelerometer are sensors that measure acceleration, which can be caused by a variety of factors including mechanical vibration, movement, and changes in velocity. In project 4, using a fuzzy logic method, it is possible to analyze the performance of the sensor over a wide range of conditions and situations. In project 5, this system uses a vibration sensor to detect the presence of a train and ZigBee technology to transmit this information to other trains and control systems. Next, we uses the component that we uses, which is firstly the SW420. The SW420 is a sensor module that can detect the vibration of or movement of an object. It uses a piezoelectric material to convert mechanical stress into an electric charge, which is then amplified and output as a digital signal. Next component, which is the which is the GPS module. The GY-NEO6MV2 is a compact and low power global positioning system GPS module that can be used to add location tracking capabilities to a wide range of applications. It is based on the U-Block's Neo6M GPS module, which is a highly sensitive and accurate GPS receiver. Next, we uses MicroSD Card. The MicroSD card are based on flash memory technology, which allows them to retain data even when the power is turned off. They come in a variety of storage capacities, ranging from a few gigabytes to several terabytes, and are available in different classes and speed. Next, we go to the conclusion of literature review. It is possible to draw the conclusion that the vibration sensor module, PLC system, and signal system are the main components of developing vibration monitoring systems. Regardless of its intended use and design, the system would not be fully realized without these two features. Introduction of methodology. After a careful review of previous project and the selection and acquisition of the necessary components, this project is now being created. Throughout the project process, a project flowchart, system block diagram, and system flowchart will be developed as a guide for the project implementation. Next is system flowchart. So it begins starting, then it initialize. The microcontroller. Then it receives the data from ESP32, which will be the coding for GPS module and vibration sensor, and it will activate both of the components. So if the vibration sensor activated, it will then receive the vibration from the railway track, regardless of the vibration. If it does not vibrate, it will it it will still receive the data from the vibration sensor, and the GPS module will continuously give the mapping, the plot of the current location, and receive the data. So then the data will be saved into the MicroSD card. So that's it for the flowchart. Next, we go to block diagram. So this is my block diagram. The main components that used for this vibration monitoring system, which is ESP32, it will be powered by power supply, and the vibration sensor will be the input for the ESP32. So for the GPS module, they communicate with ESP32 until until it turn off. So then the ESP will send the data to the microSD card. So this is the 3D layout design. It is a simple design, which is a box, because my project does not need to have a bunch of things to make to store the components. So my project components are not that many. So a box like this will be enough to carry around with me. The box, the material that I use is acrylic. So acrylic means that I can see the components inside the box. Okay, so this is the first thing here is picture, which is the 3D layout, and the right one is the front view of the box. Next, the left one is the side view, which you can see the door, the handle, and for the right, which is the top view. Hardware, for the hardware list, I use ESP32. For the hardware list, I use one ESP32, one SW420 for the vibration sensor, and one GPS module. and the power supply that I use is 3.7 volt lithium ion battery, and it comes with the battery shield. Next is the jumper wire, female to male / male to male. One micro SD card, one micro SD card module, and one breadboard. Next, we go to the software list. So I use Arduino IDE for the coding of the project. Next is the Proteus, which I use to design the circuit diagram. Next, Tinkercad. Tinkercad is a platform to design the 3D design that I use to make the box. And lastly, Microsoft Office. Okay. So last but not least, circuit diagram. Firstly, connect the SW420 sensor to the ESP32. The sensor has 3 pins, which are VCC, ground, and out. Connecting the VCC pin to a 3 volt power supply, the ground pin to the out pin to a digital input pin on the ESP32, which in this case connecting to pin 23. Next, connect GPS module to the ESP32. The GPS module will typically have a serial interface such as UART or I2C that can be used in communicate with the ESP32. Connect the GPS module RX pin to a digital output pin on the ESP32, which is pin 19, and the GPS module TX transmit pin to a digital input pin on the ESP32, which is pin 18. So that's it from my presentation of PSM1, which is the development of train vibration monitoring system for future mitigation. Assalamualaikum warahmatullahi wabarakatuh, and thank you very much.